a minute, have you heard about Sir Majesty Easy Word? Well, I'm a subscriber to at Sir Majesty Easy Word on YouTube, and I'm a student at University of Camerino, Italy. Sir Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy Word today at www.easywordscience.com and on YouTube at Sir Majesty Easy Word. Bye. Thank me later.
You're welcome to the Easy World of Science. Nice having you again. Today we'll be teaching both the way to prepare the given solution of an acid HNO3 and also the specification of sodium Trioxonitrate. And this titration is an acid-based titration. It's a common approach to volumetric analysis, of course. So I will teach you how to prepare the solution and also titrate it here for you to see the endpoint. First of all, we are going to be titrating solution A, which is required to contain 9.50 cm3 of the concentrated nitric acid in 1 dm³ of the solution over here, and then against solution B, which is supposed to contain 4.20 grams per dm³ of solution, that is per liter. In every 1 liter, there are supposed to be 4.2 grams of sodium carbonate and hydrous, of course, in it. Here we're supposed to have 9.50 cm³ of the concentrated nitric acid into this particular solution. So, definitely, we were not told the percentage concentration. For you to know the concentration, the molarity, in other words, that's the molarity of these two solutions. Solution A, we have to do some calculations on the board. Solution A was meant to contain 9, that's for solution A. We are required to contain 9.50 cm³ of the concentrated HNO3 in 1 dm³ of solution. So, for you to know the molarity, for the molarity of molarity of A, for you to know the molarity of this particular acid, where you are giving the information 9.50 cm³ of the comp HNO3, the information you need are not actually complete here. They're supposed to give you the specific gravity. If they don't give it, usually by the examiner, you find it on the stock solution, that is on the bottle, on the reagent bottle that contains the HNO3, which is usually labeled relative density or SG. Then, if your own is not labeled, you find the specific gravity. You endeavor to watch some of my titration videos here where I taught how to know the specific gravity of the acid you want to use by yourself. That is how to determine the relative density of acid. For us, the analysts, I don't rely on what they write there in the market, especially here in Nigeria, where quality is not assured in terms of chemicals, and that's why I've decided to be selling these things to you. I produce the high quality ones, and the ones I don't produce, I test the quality before supplying to you. So you are advised to buy from the Easy World of Science. You can also visit my site www.easywordscience.com or place order with the number you see there on the screen for biology practicals and the biology apparatus, physics apparatus and equipment, and chemistry. I will also help you to equip your laboratory, that is set your laboratory in a functional standard way, starting from the scratch, well organized to enable you in analysis. So, what I'm trying to say is that if your stock reagent bottle containing HNO3, that the paper label on it has torn off, that you couldn't see the specific gravity, you have to discover and verify the specific gravity of the one you have by yourself. Then, secondly, the percentage concentration is also needed, the volume by volume or weight by volume. So, normally, the common one we see in the market usually contain from 65% to 70%. And the one that is 70% have the specific gravity of 1.42 for HNO3. I've known this already. The one I have in the lab with me is 70%. Even if you don't know the percentage and the SG, you can use standardization. Always use sodium Trioxonitrate to standardize. Stay subscribed so that you learn how to standardize acids when you have it in the stock, because someone might add water to it or unknowingly dilute it more. So when you're analyzing, pre-assuming that what is in the label is what is in the container, it might fail you. So this is why you should be an authority on your own. Now, I'm going to assume now that 70% and 1.5 and 1.42 is the specific gravity. So it is already established for HNO3, concentrated HNO3 of 70% concentration, and it has the specific gravity of 1.42. From my standardization and analysis, it is automatically confirmed that the molarity of 70% HNO3, which usually have a specific gravity, that Sg of 1.42, is usually 15.8 mole to 16 mole, 16.0 mole per dm3. That is within this range, 15.8 to 16.0 mole per dm3. So in this calculation, I'm going to use 15.8. I've realized this from several standardizing I've been doing. As far as the percentage is this and the SG is this, you can discover SG by yourself, like I told you. You check the video here, you know how to know the SG of the solution. So if this is the case, I'll just say what is needed, that for HNO3 of 70% and 1.42 SG, because all the 70% concentration of HNO3 have SG of 1.2, and the molarity, I repeat this, molarity is 15.8. That's what I'll be using here. In this case, the 15.8 means 15.8 mole per dm cube. That means that if you go to the stock solution and measure 1000 cm cube, because 1 dm cube is equal to 1000 cm cube, which is also equal to 1 liter, it contains 15.8 moles. And the examiner instructed you to measure 9.5. So you now ask yourself, 9.5 cm cube will contain X. I didn't come out here with my calculator, so I'm going to get it. So what you do, you cross multiply such that 1000X is equal to 9.5 times 15.8. At the end, X alone is equal to 9.5 times 15.8 all over 1000. The calculator. Okay, by this, the evaluation is 9.5 times 15.8 divided by 1000, which will give you 0.1501, approximately 0.15. 0.15 is the molarity of solution A. So the molarity of this solution A is 0.15. So the molarity of A from my calculation, we fill it here, is equal to 0.15 mole per dm cube. So that is the CA in this case. Now let us solve for CB. What should be the molarity of B? Molarity of B, we have to go back to the information given to us by the examiner in actual sense. Don't forget that the molarity of A, we're going to put it down. Molarity of A that we got now, that is HNO3 we are titrating, we got it at 0.15. Now let us solve for the molarity of B. The information about B says that B should contain 4.20 grams of Na2CO3 per dm cube of solution. So this information is enough to find the molarity. In this case, they gave us mass. We're going to convert the mass to mole, and to convert mass to mole, we have that mole is equal to mass given all over molar mass. And the mass given was 4.2, and the molar mass of what is now the molar mass of sodium trioxocarbonate. The molar mass is, sodium is 23, 23 times 2 is 46 plus 12, automatically plus 48, so we have 46 plus 12 plus 48, which will give you 6 plus 2 is actually 8, 8 plus 8 is 16, so we have 6, you carry 1, so here is 5, 6, then 10, 106. So the molar mass of sodium trioxocarbonate is 106, and the mass given was 4.2, so 4.20 divided by 106 give us what? 4.2 divided by 106 give 0.039 on the approximate, 0.039, which is approximately giving us 0.04 mole per dm cube. So this is our CB. So in this case, molarity of A is 0.15, while molarity of B is 0.04. 4 mole per dm cube. This is our Ca and this is our Cb. Now we will do our titration now. Between these, the molarity of this is 0.15 and this one, and the molarity is 0.04 mole per dm cube. So I'm going to do the titration, then after we come back and calculate. Having known all this, one can actually manipulate the endpoints, but what matters here for your endpoints, remember to interact with your students. There is no particular endpoint that is the best, especially in this case where if the examiner did not give you the percentage concentration of the HNO3, they didn't tell you 65% or 70 or 75% concentration of HNO3, they just say 9.56 or sorry 9.50 cm of the HNO3. In this case, anything can be your endpoint, not necessarily any number, but I'm trying to tell you not to be deceived by someone telling you that this particular thing you got is wrong. But I did mine using 70%. So if you are using 65%, you won't get the same endpoint with me. If you're only 65%, your endpoint will be higher than mine. So what gives you mark or gives your student mark is how they are very close to the endpoint you fill in the report form. Get this information very clear now. There is no particular, because someone will manipulate. I know, having given you the molarity of all this, you will now go and manipulate using the equation of the reaction and say this is the best endpoint. In reality, the examiner is marking how you and your students interact. How were you able not to vary so much from a given figure? So if your students do vary with more than 0.3 from what you write in the report form, they will lose mark. But when they are within 0.2, 0.1 from what you fill in the report, you will get the highest mark. So it is you that is the teacher that is marking the student. In other way around, if you are forging your endpoint, make sure you close the gap between you and your students. But if you train your students very well, like me, when I train any set of students, I don't give them endpoints, they are just allowed to titrate. They are already perfect and they don't vary. Most of them even get correct, like the exact number after 3 consecutive titrations. Imagine that. So you can equally achieve that if you train your kids well. But if you don't, close the gap between you and them. So first, in titration, here is the buret, and here is my pipette. This is 25 ml pipette. I also have my pipette ball or pipette filler. You can also place order for your own. Together with pipette pump, I have all those things because sometimes the student might have the danger of swallowing this if they use mouth to suck. We are passing through the era of such chemistry and analysis, so upgrade to use of such pipette filler. They are cheap and affordable. Place your order at easywellscience.com for the number you see on the screen. Together with other things you might need in analysis in chemistry, physics, and biology. Even medical equipment are also available. First, what you need to do, of course, we have our thermometers. Then we also have the indicators here. Sorry. We have the indicator. Here is the methyl orange indicator. Here is also phenolphthalein. Which among these two is the most suitable? But I'm going to use the two. I will use phenolphthalein. I'll use methyl orange here and also use phenolphthalein. And let's see what happens with the endpoints. They should not vary actually. But the most suitable should be methyl orange. That's the one you will likely use. Okay? Then the white tie here is also there for you to detect color change very well. First, the funnel is there. What you need to do is to wash the buret with the acid. That should be the first step to prevent contamination. And how do you need to wash it? I'm going to be using this to collect my A and B. I'll just do it, you know, this bigger volumetric flask. So beaker B will be here, the smaller beaker will be here. So I'm going to be tapping the samples off. Okay. Endeavor to tell your student not to waste any of the reagents. I've collected more samples. So what I do first is close the tab. Fill. Remember to avoid a bubble. You are filling. So bring back and restore this to lower minuscules of the 0 mark. Okay, then that's our 0. Although this should be a kind of, I'm running this for the first time like I told you. What you need to do is just wash it with the acid. And how do you wash? Now I fill to 0, I'll just discard. That's how to wash to remove any form of contamination. Although, if you don't do this, remember your rough titration is also to adapt this apparatus. The rough is a kind of assuming you are washing the apparatus. So rough titration does what? Adapts the buret and the pipette to the reagents to be used and also predicts the range of the endpoint. That's the rough titration. So this is that. Then repeat again. This time around I'm filling the one I will use. Everyone should be allowed to explain. Super side. Then the same thing, you also wash the pipette with the base. This is my pipette. This is the base. This is my pipette filler. The fillet, fix. It's a very easy thing to use. I'm discarding this just to make sure there are no contaminations. Now I'm preparing the sample I will use. But don't forget to wash the aeronizer flask with distilled water of the aeronized water. This is the conical flask, which will hold the analyte, which is the sodium carbonate. If you exceed, gently press this together. Okay, there. That's great. Remember not to blow off this that is remaining, no problem about that. Insignificant. So next is to add, this is my 25 ml of B, adding my indicator. See the color, it has indicated yellow. So you gradual, the first titration is seen as rough, and your first titration, there is nothing that concerns you with looking at the buret, really. You look down into the tighter mixture inside the conical flask as you add, so that you can detect immediately when there is color change. Well, avoid adding excess acid. See, just a drop will not take us there. That will be very careful. Yeah. See, I've gotten it. So, from my buret reading, I have 13.5. Yeah, it's 13.5 is what I got from my buret reading from the first title. From the first title. You have, remember to how to make your table, you fill it, but I don't got time for that. You are just taking the first one I got 13.50. So I want to repeat the same thing using phenolphthalein, and let's see how it goes. To avoid unnecessary making mistakes in calculation, you need to fill back just to get into 0. Make your initial 0. You can continue from that 13.5 as your initial. Okay. I've filled to 0. So this time around, second titration, my initial is green with distilled water. This is my base. I need more base. 12. And here's my phenolphthalein. So the color of phenolphthalein is actually pink, or red. It's actually pink in base. So it's indicating where my endpoint is when it turns colorless. So it's pinkish here. So when it turns colorless, now we are at 10.5. Having done the first titration and I got 13.5, in the subsequent one, I will open this tab until it gets to 10 because it's obvious it will not neutralize until 10 or 9. To avoid wasting your time, the first titration is actually the most difficult. The other subsequent ones, you know the range where we are heading to. But some will get 13.5 and still waste their time shaking this mixture when it is still 5, it will not neutralize. So as I look at here, I also open the second titration, get to 9, we then shake, see, that's erroneous, that's neutralized even before 9. So phenolphthalein is not acting as a good indicator here. From let me carefully repeat this. So initial is 0.0, okay, it has dropped to 0.1. So I will now add gently. Let's see the difference between the endpoints when we use methyl orange and when we use phenolphthalein. See, it's giving us 8.6 minus 0.1, that's 8.5 when I use phenolphthalein. Imagine the discrepancy. In this one, methyl orange was used, then I got 8.50 when phenolphthalein was used. So which one is the correct endpoint? I'm telling you that the first one, 13.5, should be the best. So methyl orange is the suitable indicator in this titration and not phenolphthalein. In acid trioxonitrate titration, the methyl orange should be the suitable. Let me now do the calculation theoretically and see which of them is the correct one. So from the equation of the reaction, our reactants are the HNO3, HNO3 versus sodium trioxocarbonate 4 will give sodium nitrate, trioxonitrate plus water plus CO2. Anytime trioxocarbonate will react with acid, water is formed. There should be 2 here and 2 here. Aqueous, liquid, and gas. So I guess with this the equation is balanced such that the mole ratio of acid to base is 2:1 in this case. Okay. Then we want to calculate what should be the correct endpoint. We want to use CA all over CB is equal to Na over Nb. Ca is the concentration of acid, which is the molarity, and it is 0.15 from what I told you from my analysis using 70%. Then times Va will make it unknown, even though we got 13.5 and 8.5. So then divide by Cb is 0.04. Then equal to our Na is the mole ratio of acid, which is 2. Then our Nb is mole ratio of base, which is 1. So having done this mathematically, we have to cross multiply. If you cross multiply, find out that 1 times 0.15 times Va should be equal to 2 times, times Vb, sorry, I did not include Vb here. Vb was the volume of the base, which is 25, because it's equal to 2 times 0.04 times 25, such that Va alone is equal to 2 times 0.04 times 25 times 25 all over 0.15. from the calculator department, we have that 2 times 0.04 times 25 is equal to 2. Still 2. So this one will give you 2. Then over 0.15. 2 over 0.15 is 13.33. What an accurate result. 13.33, and the other one I got 13.50. So 13.50 was the correct, and the most suitable indicator here should be methyl orange and not phenolphthalein indicator. If you use 25 cm3 of B, your endpoint range should start from, even if you use 12, you are still within the range. 12 to 18 should be accepted, but from my own titration, because I used 70% HNO3 and I have my accurate measurement, I got 13.5. So which means 13.3, 13.4, 13.6 is also allowed if I am going to use this as a teacher on my practical report. If I use 13.50, any child getting 13.40 is correct, 13.50 correct, 13.60 correct, even 13.30 is also correct. So that is it for this titration and the recommended endpoint. For further guide on chemistry practical, you contact me with the number on the screen. I'll help you, especially chemistry teachers. If you're finding it difficult in salt analysis, or you're finding any production difficult for foreigners that are involved in production, industrial chemists, I'll help you in analysis and also in the production procedure and also in calculations. So, patronize me today for I give a quality service. Remain majestic and God bless you. See you. Bye for now.
I'm Dr. Kingston, a product of Sir Majesty Easy World. Join Sir Majesty Easy World today and be proud of what your tomorrow may be. Thank you and remain blessed.